Good morning. This is Naran Reddy from the Department of ECE. So in this semester, my subject is low power VLSI circuits and systems. Yeah, already you studied in third BTech second semester VLSI design. Okay, there we have seen one of the parameter is power. Okay, now as I said, the title of the subject is low power VLSI circuits and systems. The title itself represents we are going to design the VLSI systems which consumes very less power. Okay. Now let us see syllabus structure of this subject low power VLSI circuits and systems. As you know, each and every subject consists 5 units. The first unit of this subject introduces why the low power required, what are the different sources for the power dissipation, what are the various methodologies to satisfy very less power consumption. And also in the first unit you can study the construction of MOS transistor, that is internal structure, the fluid model, different modes of operation of MOS transistor and its electrical characteristics, and we can see how the MOS transistor acts as a switch. This is the thing you can study in the first unit. Then coming to second unit, in the first part of the second unit you can study how the MOS transistor can be work as inverter characteristics, inverter ratio, switching characteristics, and delay parameters we can study. Whereas in the second part, different technologies like pass transistor logic, gate logic, MOS dynamic circuits to realize different gates. Okay, so that thing you can study. Actually, this part of the syllabus you studied in the VLSI subject also. Okay, but once again we can see some little bit extra compared to that VLSI design subject. Okay, then from the third unit onwards, various methodologies we can discuss to reduce the power. Okay, let us see in the third unit what are the topics we have. Initially, again it introduces what are the reasons for the power dissipation, and we can see some expressions so that you can understand on which parameters the power dissipation depends, so that by working on those parameters you can reduce the power dissipation or power consumption. Okay, like if you see the classification of power here, the power is generally dynamic power and static power. In case of dynamic, the subclassification is short circuit power dissipation, switching power dissipation, and glitching power dissipation. Coming to static, it is purely leakage power dissipation. And second part of the third unit introduces one of the methodology, that is supply voltage scaling. As you know, the power dissipation reduction techniques you can apply at any level of abstraction of the VLSI design flow. This is one of the technique, that is supply voltage scaling. Okay, here we can study the different topics like device feature size scaling, architectural level approaches, multi-level voltage scaling, dynamic voltage and frequency scaling, also adaptive voltage scaling techniques you can see. Then in the fourth unit, here the methodology is reducing the capacitance, switching capacitance. Okay, and also we can see hardware software concept, one of the processor transmitters. So a processor, here we can see how this process in this processor we can apply the technique to reduce the power consumption. Okay, and bus encoding techniques, clock gating techniques, gated clock techniques, all those things you can study in the fourth unit. Then coming to fifth unit, the fifth unit concentrates mainly on the reduction of the leakage power. Okay, what are the different approaches are used to reduce the leakage power? And another important concept, that is adiabatic logic, also we can see here. In addition, what are the different CAD tools are available for reducing the power? Okay, so this is briefly the content in each and every unit of the subject low power VLSI circuits and systems. And the book which you have to follow to understand the different concepts of this subject, that is here the slide representing various textbooks proposed by the university. Out of this, the first one which I bolded here, Ajit Pal, Low Power VLSI Circuits and Systems. So this is the reference book. This is the reference book. In this book, each and every topic of the syllabus can available. Okay, so that is about the syllabus. Now coming to first unit. That is, okay, before going to see the content of the first unit, of course the first part of the first unit also introduction part. First of all, what is the necessity of low power? Okay, what is the necessity of the low power? Why we need to concentrate on the power parameter? Okay, and after that we have to see what are the sources for this power consumption, what are the different sources which consumes the power. So then only we can work out to reduce the power consumption, and what are the various techniques are used to reduce the power. Okay, so then coming to first of all, why low power? Now let us see the contents like why low power and power versus energy concept, the sources of power dissipation, why the leakage power is very important nowadays especially, and what is the impact of process parameter variation, and finally low power design approaches. These are the topics I would like to discuss now actually with reference to the syllabus. Okay, first of all, coming to why low power means. Okay, you know, nowadays almost all electronic gadgets, whatever the electronic gadgets the people using, work on battery, right? So suppose if the power consumption is high in the system, what will happen? The battery life is very short. Okay, the battery life is very short. Within a very short time period, you need to replace the system with the new battery, right? Suppose if the power consumption is very less, means no need to replace the system with the new batteries within a short time. Okay, so that is one thing why we need to concentrate on the low power. Okay, then changing trend means, so what happens is, so until recently the performance of the system means that is speed. In earlier days, the scientists didn't concentrate on the power consumption parameter. Okay, but nowadays, along with the speed, we also has to be concentrated on power consumption. Why? Because with the submicron technology, submicron means nanometer technology. Okay, in submicron technology case, what happens? because of reducing the size of the device, because of reducing the size of the device, more number of devices we can place within a given area. So that what happens is the power dissipation per unit area is large. The power density, that is the power density is large. Okay, so that is the reason why we need to put concentrate on the reduction of the power. Okay, so in nanometer technology, the transistor count is increased, the speed of operation also increases, the power consumption is directly proportional to speed of operation. So if the speed of operation is high, the power consumption also high. Okay, so that and another thing is leakage power, or leakage power is because of the leakage currents. Okay, the leakage power is because of leakage currents. Okay, so in nanometer technology case, we must concentrate on leakage current also, even though its magnitude is very less. Okay, in the nanometer technology case, even though it is a very less, but its effect on the power consumption is large. So that's why we need to uh, concentrate in the power reduction techniques. Okay, so that is the changing of the trend. Then another reason why we have to concentrate on the power consumption is package and cooling cost. Okay, package and cooling cost. So the power consumption appears in the form of heat. In the form of heat. So when the heat of the system is increased, what will happen? The components may burn. When the component of the system may burn, what will happen? The system may not work properly. Okay, so proper cooling arrangement we need to provide within the system. Okay, so usually the cooling systems are heat sinks, fan, and AC we are going to provide where that system works in general. Okay, so if more power consumption will happen means more heat will be generated. Okay, when the more heat will be generated, to reduce that heat, we are going to arrange some cooling mechanisms. Okay, so the cooling mechanism cost may increase if the power dissipation is increased. So that is the uh, reason why we have to concentrate on the low power. Okay, so here the slide represents various processor developments from the 386 to Pentium 4. Here if you can observe that the power is increased by from processor to processor like this. Okay, so with the advanced process, whatever the Pentium 4 is there, it consumes more power compared to the earlier Pentium processors and the basic processors. Okay, and another point is we have to concentrate. Okay, that is power density. Power density is increasing. Power density is increasing. As I said that the number of components per area will be increased by the technology, so that power density is increased. Okay, so because of power density incremental, the heat generated in the IC also increases. Okay, so in Pentium 6, if you observe this slide, in Pentium 6, almost the amount of heat generated in Pentium 6 is equal to the heat at the hot plate. The heat at the hot plate. Okay, that much of heat you can observe in the Pentium 6 processors. Okay, so high amount of heat is generated because of reducing the size of the device. Okay, when the device size reduction means more number of devices are going to place within the given area. Okay, and the next reason is uh, portable systems. Portable systems means that is nowadays people preferring portable devices like cell phones, PDAs, palm tops, laptops, etc. All these work on battery, all these work on batteries. Okay, but the battery technology may not be uh, may not be equal to the technology of integrated circuits. Okay, so that's why uh, we have to concentrate on the power reduction techniques. Okay, and another reason is reliability. That is, uh, reliability means if the perfect operation. Reliability means perfect operation. Okay, so that is, by increasing the power consumption, the heat will be increased. Because of heat, some components may burn. If the components burn, means we can't expect the result whatever we desired. Okay, so if you see here, these are the various reasons for reducing the reliability. Okay, so because therefore the scientists can say that for every 10 degrees centigrade rise in temperature, roughly doubles the failure rate. Okay, the failure rate doubles for every 10 degrees centigrade rise in temperature. Okay, so to avoid that one, uh, we need to concentrate on the low power systems. Okay, and another thing is environmental effect. It also affects the environment. Okay, so what will happen when the power consumption appears in the form of heat, and because of the cooling system whatever we are arranging in the system, that cooling system, uh, what is the functionality of cooling system? It transfers the heat from the system to the environment. Okay, so the environment can be get heated. Okay, so yeah, the power whatever the power consumption occur in the electronic system, it affects the environment uh, conditions. Okay, so to in order to avoid all these uh, actions, we need to concentrate on the low power systems. Okay, so that is the importance of the low power. Okay, so what for low power systems? Okay, or why we need to concentrate on the low power systems? Okay, so what are the reasons? Because of changing the trend, and to reduce the packaging and cooling cost, um, to get the reliable operation, to reduce the effect of on environment. Okay, and to reduce the power density. All these are the reasons we have in front of us to reduce the to concentrate on the low power techniques.